method, I calculated only the time time contraction in the longitudinal direction, and I have used the transverse value from Einstein's equations. That is not my construction. You did not notice it. I did not explain it anywhere. What I did, yes, in my calculation I have used only the movement in the longitudinal direction, and our equation is different from Einstein's one. And I consider his one as in the transverse direction and took the product of those two. One of those is actually calculated by me, by us. Okay? So I have it. Or do you have any more questions?
Regarding the contraction of length, it is always transverse, and longitudinal contraction was never observed, since relativity theory. And in the theory of relativity, it is said that there isn't any contraction along the lateral direction, along the transverse direction. So that is one thing. And second thing, regarding time, as the first questioner asked, we never heard of anything like transverse or longitudinal time. Time is time. My question is like the first question, like what do you mean physically by the transverse and longitudinal time? By time, you mean time.
Can I make a point about this question? X, the time coordinate is switching transverse to the x-axis. So the contraction is around t, and that is transverse to the direction of motion. In that way, you can make sense of this transverse time dilation. The other question is, I think we can put it very simply, whether we can consider time as a vector. That is, I think, one of the most important questions. Because if you cannot assign a direction with time, then in physical sense, time in transverse and longitudinal direction does not have any meaning.
Okay. Let me answer the length. The relativistic effect on length has been derived or calculated in both directions. In one direction, it remains invariant, and in the other direction, it is contracted. So, my question is, if it can be done for length or measurement on length in both directions, why should not it be done in the case of time also? And in fact, in the calculation, I cannot explain right now. Explain it right now, but probably so far I know they consider in both directions, but they did not find anything in the longitudinal direction. That's why they don't mention it. And as I explained to you, just a while ago, that we have got the relativistic effects in both directions. That's why we have to mention that it is in the transverse or it is longitudinal. And he had only one quantity, that's why he did not mention. But those are actually calculated or calculated in that. I'm very sure about the length measurement in that book, in one book I have seen that one. That in the transverse direction, L is equal to L0. And in the longitudinal direction, L is equal to L0 to 1 minus V square or C square. So, this is not a new concept in fact. This has been done before, but they came up with the result that in the other direction it does not vary. That's why they talk about only length or time. Sorry, am I clear, sir?
Still it is left for a fundamentalist to do this, as Dr. Nakib Ahmed and Dr. Shamsuddin Tariq. They are the young, energetic, enthusiastic, and also a talented scientist, and we are proud of them. So I think the task is left for him to verify experimentally. Thank you.
Science and Technology today, and Professor, Department of Physics, University of Rajshahi, kindly take his seat as the chair of the session. Thank you, sir.
Today, the first speaker will be Professor Mushfiq Ahmed, and the title of the paper is Incompatibility between Einstein's postulates and Special Relativity. So I will request Professor Mushfiq Ahmed to come and present his paper.
Postulates and Special Relativity. Mushfiq Ahmed and Professor Mohammed. The theory of relativity is based on Einstein's postulates. And about to say that incompatibility between Einstein's postulates and special relativity seems contradictory. But in fact, that's what we're going to study, whether it really translates faithfully, that is the theory of special relativity. Does it faithfully translate Einstein's postulates? The first part is triviality of Einstein's postulate, Einstein's statement. We should see, I'm saying in advance, the upper scale U, we should call it the Galilean representation, and the small scale U, small u, is the corresponding hyperbolic representation. They represent the same physical quantity, but in two different spaces. One is in Euclidean space, what we call Galilean, and the other in hyperbolic space U. And that's related to these transformation relations. U by C, again in the one we have introduced, this is just a constant. Constant speed, and this is U in Galilean representation or Euclidean representation. And the correspondence is this. U C is equal to tan H, U by C, which is hyperbolic content of U by C. So this is the small U in hyperbolic space, and this is the big U in corresponding Galilean space, and this is the definition where we name C, U by C, by that and make this problem. The Galilean related velocity, but we are considered in the experience. If U is the body moving with velocity U, and V is the velocity of the observer, the rate velocity U by V, we call it W. By this transformation, this corresponds through this hyperbolic transformation. For U is this transformation, for minus V is corresponding to this minus V, and this addition or subtraction will be replaced by multiplication because we are in the hyperbolic space. So addition, addition corresponds to multiplication here, and that gives us this quantity corresponding to this W. We have now this small W, which is defined again by this quantity. Where by this small W is this. So corresponding to Galilean relative velocity, U by V, as you know, we have replaced it by this relation, which is Einsteinian addition. And here we are always dealing with motion in one space dimension. If U minus V is C, this special value, then this becomes, instead of minus we have C here, and that gives us C, which corresponds to Einstein's postulate. But of course, we are talking not from Einstein's postulate, but from this, the transformation will be introduced, hyperbolic transformation, which is isomorphic. Now, what do you mean by this C and what it corresponds to? V by C is tan hyperbolic of capital V by C. If V is replaced by C, as in here, it becomes C by C, which is 1. And therefore, this has to be infinity because 1 as the value corresponds to infinity of hyper in the hyperbola space. Therefore, U plus infinity, and with some modification of extension, we was what we call V here, minus it was minus sign now equal U plus infinity. Of course, U plus infinity is infinity. What we get is Einstein's postulate is faithfully translated with the speed of light is invariant, but it means the speed of light is infinity, which makes it faithful but trivial. So we could do that Einstein's postulate is equivalent to stating that the speed of light is infinite. As far as the postulate is concerned, that it is invariant, we accept, but its meaning is because saying infinite and invariant do not mean anything here. In this small session, there are two different papers. The first, what we already said there, a few minutes, and now is the second part of the paper, which is in fact an independent paper, a short paper. Here,
excuse me, do you like to have the questions now or after two presentations?
Two presentations.
Okay, that's fine.
Now, we want to study the associativity of laws and transformation. The first part was related to the first postulate of Einstein. What was it? That the speed of light is invariant. The second postulate is that it's the same in all inertial fields. And we're studying that now. But this is Einstein's law of tension of velocity. Previously in the morning session we have seen this part only because we were dealing with motion in one dimension, and in that case that part cancels out. But the general formula of the Einstein's law of tension velocity is this. And this, I will put this, and this is not associated, which means this is an inequality sign. If we add u b first and then y, it does not give the same thing as if you add vy first and then u. Which means if there are three velocities, u, v and w and y for example, and we want to find the resultant velocity, we have to do it either this way or this way. If we do it this way, we add the u first, we get one result. If we do it the other way, v and y first, we get another result, which means we do not get any unique result. And if it's not unique, it's not meaningful. Therefore, loss transformation does not give a unique result. So this is